All right, today we're going to work on the second part of lesson 6.1, which gets into starting to solve some one-step inequalities. We're going to work on solving these inequalities using the same techniques we use to solve equations. They're just one little rule that we have to keep in mind, and that comes when we multiply and divide. If it's done using a negative, then we got to switch inequality sign. You're going to see that here in a moment. All right, one of the first things we'll do is just talk about an inequality one-step equation and look at how answers actually work in this thing. So here we go. We're given that in our first inequality here, 12 is greater than y minus 28. It wants to know if y is 39, is that a solution to this inequality? Okay, so the process here is to simply take your inequality, substitute 39 in place of y, simplify it, answer the question. Is 12 greater than 11? Yes, so 39 is a solution. Okay, is 36 a solution? Well, put 36 in place of y. Is 12 greater than 8? Yes, 36 is a solution. Is 43? Well, put 43 in place of y. Do the subtraction here. 12 is greater than 15. That's false. So 43 is not a solution. And then is 40? Okay, well, 12 is greater than 40 minus 28. 12 is greater than 12. That is not true. 12 is not greater than 12. Okay, those two are the same. Okay, now another one, this one involves multiplication. So I want to know, are these values for x, 9, 5, 12, and 11? Are any of those answers up here? And the thing about inequalities that I haven't said yet is they can have all kinds of, there can be a infinite number of possible answers to this problem. When it was an equation, there was one answer. Now we got an infinite group. Okay, so let's look at the first one. Plug 9 in place of x. 3 times 9, 27 greater than or equal to 27. Yes, it's equal to 27, so 9 is a solution. Try 5. 3 times 5, 15. Is 15 greater than or equal to 27? Nope. So 5 is not a solution. Put 12 in there. 36 greater than or equal to 27. Yes, that's true. So 12 is a solution. Is 11 a solution? Is 33 greater than or equal to 27? Yes. Okay. So again, inequalities can have an infinite number of solutions. All right. And here you see a variety. All right. When we solve inequalities, okay, it's the same concept as solving an equation. Same concepts. Okay. So for example, the first thing we're going to do, given an inequality, is we're going to simplify each side of the inequality sign. Distribute, combine like terms, simplify it to as few terms as possible. The second step is to isolate the variable term. So that means get the term that has the variable in it by itself on one side. Usually we like to have it on the left. Okay. So in this step, generally we are adding or subtracting to eliminate a term to get the variable term by itself. And then the last thing you'll have to do is to make sure the variable coefficient, the number being multiplied by the variable, make sure that's 1. We do that by dividing. We can multiply by the reciprocal. If it's a fraction, we have a couple different ways to do it. Here's where the one catch comes in. If in this step we multiply or divide using a negative number, then we have to switch the inequality sign. Okay. It's not about the answer. It's about what you're using in that step. All right. And I'll show you a few different examples of that. All right. So let's look at this first one. So solve for C. C minus 12 is greater than 65. Simplify your answer as much as possible. So I'm going to take this, think of it now as an equation. There's my left side, there's my right side. On the left side, I got two terms, C, and really it's like a negative 12. On the right side is 65. There's nothing I can do to simplify it. There's my variable term C. I want to isolate it, so I want to make this become 0. So I'm going to add 12 to both sides. Negative 12 and positive 12 is 0. So I get Z is greater than 77. Done. Okay. So what we're saying is, as long as you pick a number bigger than 77 and put it in place of C, this is going to be true. Any number bigger than 77. So again, there's an infinite number of answers here. Do another one, negative 6 less than or equal to negative 14 plus V. Now, I did say this earlier, and we need to get used to doing this. We want to have the variable on the left. Okay. Now, I can interchange the two sides, but I also got to change the inequality. Because what we're saying is this negative 14 plus V is bigger than -6, or -6 is less than this one. So if I switch sides, I can do that, -14 plus V, but I got to switch this. Okay. So this statement is the same as this one, but now the variable's on the left. Now I want to isolate my variable term. So I want to make the -14 become 0. I'm going to add 14 to both sides. I get V is greater than 8. So as long as I put a number in place of V that's bigger than or equal to 8, this will be true. These are all my answers. Okay. Whoops. Next one. Now we do it with decimals. Doesn't change anything. But again, see my variable terms on the right, I want it on the left. So I'm going to switch sides, switch the inequality sign. Now solve it. Get y by itself. I want to make this a 0. So subtract 3.4. I get y is less than -4.9. As long as I pick a number less than -4.9 for y and put it in here, this stays true. Okay. Do it with fractions. So I got w plus 2/5 greater than or equal to 1/6. Nothing changes. I want to isolate w. I want to make 2/5 become 0. So I subtract 2/5 from both sides. We know 2/5 minus 2/5 is 0. This part, you guys probably put in a calculator, but you don't have to. 1/6 minus 2/5. Okay. To be able to do this subtraction, we have to have a common denominators. So I'm going to make them both have a denominator of 30. I'm going to multiply top and bottom over here by 5. And the numerator denominator in this fraction by 6. And that's going to give me 5 over 30 minus 12 over 30. 5 minus 12 is -7. So -7/30 is the answer to 1/6 minus 2/5. So the answer is W is greater than or equal to -7/30. Okay. Whether it's decimals, fractions, whole numbers, integers, we do it the same way. All right. Now looking at multiplication division. So here's my inequality. 12W is greater than 60. Okay. We got to find all W's that make this true. Well, this W term is isolated. Okay. It's on the left by itself. What I don't like about it is it's 12 times W. I want that 12 to be a 1. So I make 12 become a 1 by dividing both sides by 12. This 12 divided by 12 is 1. 60 divided by 12 is 5. So the answer is W gives me greater than 5. Okay. Another one here. So this one, notice again, the variable terms on the right, you want it on the left. So switch sides. Okay. I switch the two sides. I change the inequality. Now I want to make, this is my variable term and it's isolated. It's over here by itself. Now I want to make that -4 become +1. Okay. Because I want to know what W equals. So we're going to divide each side by -4. When we divide by -4, since we're dividing using a negative number, I got to switch the inequality sign. Okay, so now it goes back to less than. -4 divided by -4, +1. -16 divided by -4, +4. There's my answers. Any W, any number that's less than 4, you can plug it into this inequality and make it true. Okay. Fraction times a number. Okay, so I got 2/5 n less than or equal to -18. I want to isolate the n. The term's already isolated, but I want to make this 2/5 become a 1. I make 2/5 become 1 by multiplying by 5 over 2. When you multiply by its reciprocal, the denominators cancel out with the numerators, and I'm left with 1. Now, 5 halves, I got to multiply both sides by 5 over 2. I'm going to treat 18 like -18 over 1. When I multiply fractions, we can cross cancel. So 2 goes into 2 once. 2 goes into -18 -9 times. 5 times -9 is -45. Notice I didn't switch inequality sign. My answer is negative. That's where some people make a mistake. They say, well, I multiplied a positive and negative, got a negative, so I should switch the sign. No, you switch the side based on the number you're using. +5 halves, +5 halves, sign stays where it is. Okay. So there's our solution. One more. 8 greater than or equal to -10/7 U. Okay. I want the variable term on the left. So I'm going to switch sides, which makes me switch inequality. Now I want to make the U's coefficient, which right now is -10/7. I want that to be a +1. So I'm going to multiply each side by -7/10, the reciprocal of this. -7/10. See, a negative times a negative over here is positive. The 7s, the 10s cancel. That gives me +1. Because I'm using a negative number to multiply on both sides, I got to switch inequality sign. And then over here, I just need to simplify it. So cross cancel here. Divide both these by a 2. This will be a 5, right? This will be a 4. And if I multiply, I get negative 28 fifths. Now, you can leave it like that. That's fine. Or you could write it as negative 5 and 3 fifths. Or you could write it as negative 5.6. They're all the same. Okay. And I don't think it matters which one you use. Okay, but there's a little look at how we solve basic one-step inequalities. It's pretty straightforward. Guys, write this work down. Don't try to do it in your head. Just write it down. Get used to the process. See it, do it. You'll understand it, and that will help you later on. All right, I'll let you get at it.